Algebra 1, Section 4.2, solving inequalities using addition and subtraction. If I were to give it an alternate title, I might call it one-step inequalities, or solving one-step inequalities with addition and subtraction. I've used the balance scale description before. I didn't draw anything, but when we talked about when we were solving equations in Chapter 3, you could think about a balance scale, or again a seesaw, teeter-totter kind of thing. And with an equation, it would be like this is straight across, and you've got a balanced weight on either side. Well, now we're dealing with inequalities in Chapter 4, and there's a similar analogy that can be made, and that is that if let's just say that these are weights, and this is 8 pounds and this is 3 pounds, obviously this is what would happen on a balance scale. Okay, the 8 would weigh down farther than the 3. And here's the question: what if we then added 4 to both sides? Wouldn't the sense of the inequality stay the same? Wouldn't this then be 12 and this is 7, and you'd still have the heavier weight here? What if you took away 3? Really, if you add any number to both sides of an inequality, or subtract any number. Now we'll deal with division and multiplication in the next video. But with addition and subtraction, it's always going to keep the sense of the inequality, right? So basically, when we're solving inequalities, we can solve them just like an equation. Whatever you do to the left side, you have to do to the right, and the sense of inequality stays the same. Now, again, there's a big exception to that when we start dealing with multiplication and division, but that's the next lesson. We don't deal with that here, okay? So with that in mind then, with that simple rule, what we need to do here is ask yourself what's happening to the variable, and then undo things in reverse order. Our variable is being subtracted by 3. We want to add 3. And that would get x by itself. 5 plus 3 is 8. And then you want to keep this inequality sign. It's really easy, especially coming out of Chapter 3, to let this kind of merge into an equal sign. It's not equals, it's less than, and you want to treat it that way. Okay? So x is less than 8 is the answer. What about this next one? Our variable is being added to 5. We want to subtract 5. I show in blue what you really don't need to show, right? You really don't need to show that as part of your work. But what would happen is that 12 minus 5 is 7, and keep less than or equal to. The 5's drop off there, because 5 minus 5 is 0, and you're left with 7 is less than or equal to x. I would very much prefer you to switch that around. This can be read from right to left. It says x is greater than or equal to 7. I think I mentioned that in the previous video. Yes, this is the less than sign, but if you read from right to left, it's x is greater than or equal to 7. So here you have x is greater than or equal to 7. Okay. Can you check? You absolutely can check an inequality. I don't usually require you to do so, but I want you to at least see how it would work. A check for an inequality is actually 2 steps. Step 1 is to check the number, and step 2 is to check the direction. So if I were going to check and see if x is greater than or equal to 7 actually is the solution to this inequality, what I would do is this: 12 is equal to 7 plus 5 with a question mark. And I know that's obvious, but you know that what we're going to be solving here in a couple of sections is going to be a little bit more difficult than this. So I'm just showing you the check when problems are easy. And yes, I do mean to say equals, right? Because I'm checking the endpoint, okay? And then the other thing you need to do is check and see if the direction is correct. So pick something that's greater than 7, okay? So we'd be wondering if 12 is less than or equal to 8, right? Because 8 is greater than 7 plus 5. And if both of these things are true, then we're accurate here, okay? Now, 12 is, of course, equal to 7 plus 5, so that checks. 12 is less than 13. Actually, what I really should do is not even include the or equal to here, right? Because we're checking the direction, it's going to be less than. 12 is less than 8 plus 5, which is 13. So that is how you check. Now, as far as graphing goes, x is greater than or equal to 7. Here's 0, 1, 2, 3, 4, 5, 6, 7 right there, 8, 9, 10. Good enough. Greater than or equal to 7 would be a closed circle at 7 and shading this way. And that again kind of goes along with the check. What did I check in the check over here? Well, I checked that 7 is the end point on this here. And then I checked that something greater than 7 actually is in the solution set, right? So 8, here's 7, here's 8. It's on the solution set that we graphed. Incidentally, I didn't graph this one up here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I tend to just do the same thing every time if I can. So I always go by ones and label every 5 or so. Open circle at 8, shading this way. Okay. One more example. This says in order to receive a B in your literature class, you must earn more than 350 points of reading credits. And last week you earned 120 points. This week you earned 90 points. How many more points must you earn to receive a B? So now you're going to write your own inequality and then solve what you wrote. So you got 120, and then you got another 90, and then you've got the points that you still need to earn. Let's call that P. And that needs to exceed 350. Did you notice that it didn't say at least 350 points? It says more than. If it said at least 350, it'd be greater than or equal to, but more than suggests that it's got to be above 350. So this is 210. Just combining like terms, and then subtract 210 from both sides, and you'll get 140. The amount of points that you still need to earn is greater than 140. Now, assuming that points are whole points, I guess you could say 141, but I don't know. I sometimes do half points with one grading quizzes and tests. So really, 140.00001 would be greater than 140. But anyway, that's the solution to this problem. Something more than 140 points. Thanks for watching.